RHS Pre-Calculus presents Battleship, the Unit Circle Edition.
Commander, we have 16 enemy battleships incoming on our current position.
No problem. The radar here says they're exactly 1 mile away. With our basic knowledge of trigonometry, we can easily find the coordinates of the battleships.
Golly, I can't believe that they're all exactly 1 mile away from our cannon, which is only able to shoot as far as 1 mile. But how are we supposed to use trigonometry? Doesn't that have to do with triangles?
You couldn't be more right. We have to use basic triangles to find their coordinates. Lucky for us, the enemy is at 210, 45, 240, and 90 degrees from our cannon's base position.
But what about the other ships?
Calm down, son. I'll show you an easy trick to deal with those.
Alright, let's get started. How would we find the coordinates for the ship at 0 degrees, sir?
Well, if we drew a circle from the radius of exactly 1 mile with a center of 0, 0, where we are, we know the ship's coordinates is at 1 mile, or 1 plus our x value.
Which is at 1, 0. Can I fire at the ship?
Do the honor, son. Excellent work, soldier. Now let's tackle the ship at 45 degrees.
How will we do this?
It's quite simple, really. Let's picture a triangle with the angle measurement of 45, 45, and 90. We know that the length of side C is 1 because the circle's radius is 1, and we can find the lengths of the other sides A and B based on the Pythagorean theorem.
Isn't the Pythagorean theorem a squared plus b squared equals c squared?
Of course! I'm glad you know your math formulas. We can substitute the variable c for the value 1 based on the length of c. We also know that the triangle is an isosceles because two sides have the same angle. If they have the same angle, they have the same side length. Therefore, we can safely substitute the value of b and a. Solving the equation out, we get...
We get the 2a squared equals 1, which further simplifies to a equals the square root of 1 over 2.
Good job, Sonny, but we can't leave it at that. If you further simplify it by rationalizing the denominator, the expression becomes square root 2 over 2.
So the coordinates of the new ship are at square root 2 over 2 over square root 2 over 2.
Fire and we'll soon to see.
Hurrah! How do we find the coordinates for the ship at 210 degrees, sir?
Use a right angle with the angle measurements of 30, 60, and 90. The radius of the circle is 1 mile, so the hypotenuse is 1 mile. The longer side is square root of 3 over 2, and the shorter side is 1/2.
I remember that. So the coordinates are square root 3 over 2, 1/2.
Because they are in the third quadrant, they are both negative.
So negative square root 3 over 2, negative 1/2?
That's right, soldier.
This is so much fun, sir.
Let's blast that ship to smithereens. Plug in the coordinates. And fire!
Hooray! There is another ship at 240 degrees. How do we find the coordinates for that one?
Elementary, my dear soldier. Simply use the 30, 60, 90 triangle this time. The short side is against the x-axis.
So the coordinates are negative 1/2 square root 3 over 2?
Fire when ready.
Yes, sir. Hooray!
And with that, we have gone over all the methods.
Wowee! So what is your trick with the other quadrants?
Well, they are all the same points.
All the same points?
Yes, all the same points. Unlike the degrees and radians that grow as we go around the circle, the coordinates stay the same with minor differences. The second quadrant has points as the first, the same points as the first, except all of the x values are negative. In the third quadrant, both x and y values are negative, and in the fourth, only the y values are negative.
I still don't get how the points are the same as the ones in the first quadrant. Shouldn't there be more of a change?
No. Remember, we're using the same triangle as the other points, and a triangle side length won't change because there is another quadrant. That's silly.
Wow, this reminds me of that old unit circle that I had back in my bunk.
That's because this is the unit circle. You had one all along. What are you still doing here? Go get it.
Sir, yes, sir.